In this video, I will be creating a program that will determine whether an input number is odd or even. It is best to name your program file depending on what it does. I will name this program file as oddevenNumber.c, or you can simply choose from this drop-down button, then click Save. I will write a description of the program using the multi-line comment. Next is the preprocessor directive to include the stdio.h library, so we can use the printf and scanf functions. I will declare a variable named n, and this is where we will store the input number. The data type of this variable is integer. This is our variable declaration. Using the printf function, we will display something that will let the user know what does the program do. We will also display a message to let the user know what to type in. To accept the user's input, we use the scanf function. We use the %d format specifier since our variable has a data type of type integer. We use the ampersand to signify the address of the variable n, meaning this is where we will save the input number. Possible output would be either odd or even. If you entered 8, output should be even. But based on our program, we have odd even. Therefore, we have a runtime error. The program was compiled, but the expected output is not displayed. To solve this, we need to have a condition when to display odd and when to display even. We will use a conditional statement, specifically the if-else conditional statement, since we will only have one condition but there are two possible outputs. The general form is if, open and close parentheses, then this is where you will place your condition. If the variable n is equal to 1, it is odd. Else, if our condition is false, we will display even. If we entered 1, we have odd. If we entered 2, we have even, which is correct. But if we entered 3, it says even, which is still not correct. This is because every number entered except for 1, this condition will become false and will display the statement after the else part. To solve this, let us modify our condition. We could say that aside from n is equal to 1, we add or n is equal to 3, or n is equal to 5, equal to 7, and equal to 9. 1 is odd, 2 is even, 3 is odd, 4 is even, up to 9 and 10. But what if we have 11? Again, it is an incorrect output. 11 is an odd number. That is because our condition will only check whether n is equal to 1, 2, 3, 5, 7, or 9 to display odd. Otherwise, other numbers aside from these 5 given numbers will display even, which is incorrect. To solve this, we need to analyze what is the definition of an odd or an even number. An even number is divisible by 2, meaning if we divide a number by 2 and the remainder is 0, therefore that is an even number. And if a number is divided by 2 and has a remainder, it is an odd number. We will use the modulus division to check the remainder. We divide the input number using the modulus division. We divide it by 2. The result here would be the remainder and not the quotient. If it is equal to 0, the number is even. But if the remainder is not equal to 0, therefore it is odd. We may also change our operators in the condition. For example, instead of equal to, we use not equal to. Therefore, we will also change the possible output. If the number is 1, odd. The number is 2, even. The number is 10, even. The number is 11, odd. How about trying a bigger number? 789 is odd. So as long as the number entered when divided by 2 using the modulus division and the result is not equal to 0, the display should be odd. Otherwise, if this is false, the result would be even. Take note again that an even number is divisible by 2. That ends the video lecture on the demonstration on how to create a program that will accept a number and determine whether this number is odd or even. Thank you for watching.